Good morning, everyone. I hope our sessions so far were useful to you. This is the third session on definition and examples of metric spaces. Anyway, let's have a round. Let's leave a hi in the chat box if you are online so that we can slowly start off with the discussion. Good morning, Gerald and Mahesh. So, let's quickly recollect what we were up to. And again, I remind you, just leave a hi so that I can know who all are online, and we can have the session more interactively. So let's quickly recollect what we were doing. In the first session, we talked about the definition of metric spaces. Only prerequisites which were asked of you was knowledge of definition of sets, and along with definition of function and some of its properties. So we talked about how these four conditions are important, but at the same time, when we usually talk about definition of metric spaces, the only four conditions that we talk about are these four, the numbered conditions. And we notice that that's a huge mistake, because unless we specify the domain, the range, and unless we say that m comma row is a metric space, it's an ordered pair, unless we say that this row is a metric for m alone, we are making mistakes in our definition. So next time someone asks you for the definition of metric or metric spaces, be quick to uh, quote all the correct conditions, not just these four conditions. Now, yesterday night I posted a video of discussing the same definition which we discussed in the first class, for those who missed it. And the other contents of this live session series will also be published as videos and will soon be shared with you. To know how to get in touch with us and to get updates about all these activities, the links to our links to our Facebook, Telegram, and other groups are given here, or you can simply click subscribe along with the bell button here, notifications. So yes, I hope it's back online, Bijal. Good morning. So let's quickly recollect. We talked about two examples. One was absolute value metric or Euclidean metric. And let me emphasize on the word Euclidean metric today, because we are going to talk about it a bit more in coming sessions. So, coming slides. So, and then we talked about discrete metric, the magical metric which makes our life a lot simple. To go from anywhere to anywhere, it's just 1 second. To go to any function there is very smooth, as we said. So we talked about this magical metric called discrete, and we also noticed something interesting about this discrete metric, that this discrete metric works on any given set. It was pointed out by Nikita. And then I also talked about the idea of abstraction and why it is important in mathematics education. Abstraction, how the idea of distance was generalized into the idea of metric spaces, as we saw already. And that process of making a real world idea, writing it in terms of mathematics, a language which is precise and we know well, is called abstraction. And we also talked about some properties that we observed from the initial examples that we followed. Absolute value metric we first observation was that one set may have different metrics. Second property is that same metric may work on different sets. Third, that we can find a metric on any given non-empty set. Hi Bijal, to address your query, yes, the session has started and it's online now. So with that in mind, let's go back to what we were doing yesterday. We were doing some challenges yesterday, and those challenges helped us understand a bit more about definition, and it was helping us train ourselves to think in terms of applying the definition we learned in the context of applying the definition we learned in the context of problem solving, applying the definition to solve problems. So today we will start with the last challenge we did yesterday, and then we'll go ahead to a few extra challenges. So get ready with your pen and paper, and also be ready to type in the answer to involve in the discussion. Vivek will be there. Either I will address it straight away or Vivek will be there to address your doubts anytime. So the last question we did yesterday is emphasizing on the fact that a metric is nothing but ordered pair m comma row, where row is a metric space is nothing but ordered pair m comma row, where row is nothing but a metric for m. Now few of the viewers had doubt on the same, so I am going to quote this again. We notice that by the definition m comma row is called a metric space, that is the ordered pair is called a metric space. Here R with absolute value metric row is mentioned, and by our definition option D alone is correct, because row this absolute value metric is defined on R and it's an ordered pair, hence it should be given in the right order, R comma row. That's how we eliminate the first option. Row comma R is not a metric space. I'm emphasizing on the fact that it's an ordered pair. C, R square comma row is not a metric space, because row is a metric on R, not R square. But about B, I was very specific in saying something. 1, this is not correct according to the definition, but sometimes it's much harder to write this tuple all the times, right? To say R comma row is a metric space, or the metric space R comma row, let it have these properties. So what the textbooks would do is, after mentioning that when we say R is a metric space, by default we assume that R has absolute value metric. So that's what I mentioned towards the end yesterday, that to simplify, when we say R is a metric space, what we mean is R is associated with absolute value metric. If R is associated with discrete metric, we will not say R is a metric space. We will have to specify that R is a metric space with discrete value metric. So when we simply say R is a metric space, we mean R with absolute value metric. Say yes, Bijal, so same metric can work on different sets. Or so do we need to check that way for option C, sir? You can easily check, but the problem is rho is not defined on R square. So rho is a function which is defined on R cross R to R, where we know that by definition, but if rho needs to be a metric on R square, it has to be a function from R square cross R square to R, or a subset of closed interval 0 comma infinity. So here rho is defined, rho is absolute value metric. We know that absolute value metric which we defined earlier. Let me go back to that slide. So rho, the absolute value metric which we defined earlier, is defined from R cross R to R. Hence, rho cannot be a metric on R square. Is that clear, Bijal? Anyway, uh, if there is any further question, you can post it in the comments and Vivek will get back to you as soon as possible. Continuing, we are going to do a few extra challenges. It's going to be like yesterday, but it's going to be it's going to be very easy, but it's going to be worded very carefully so that it's aimed at making you think and apply. And this time, I will avoid giving you hints on how to solve it. You can think about it. You'll have to post the answers. But when you post the answers, as I told you yesterday, wait for 30 seconds. Let everyone have a moment to think about it. And when I say post the answers, all of you can leave your comments together. Those 30 seconds you can use it to type in the answer and keep it ready. And when I say post, you can leave your answer straight. Bijal, so to add, yes, we'll talk about Euclidean metric. I think I get what you're confused about. So we'll talk about Euclidean metrics towards the end. So by then, if your doubts still persist, we will discuss it further. Now, the first question is simple. Do not post the answers until I tell you to. Let me read it. Can a function given by rho from m cross m to minus 10 comma 15 given by rho of x comma y is equal to 0 of x is equal to y minus 1 of x is not equal to y be a metric on m? Why or why not? Think about it, and when I tell you, you can post the answer here, you can go ahead with it. So think about the question now, and please feel free to get involved in the discussion because it helps me know how far you have understood. It helps me know how well you have understood. So feel free to drop your thoughts, whatever it is. Whatever it is, your thought may be a new perspective nobody else has thought about. For example, Nikita pointed out something 2 days back, right? It was a wonderful point. Is there a metric which works on every possible sets? It was something new that all of us learned together. So whatever it is, leave your thoughts here so that we can discuss. Now, I hope the time is enough. This is an easy question, so you can post your answers right now. You can post your answers in the comments now. Yes, -1 doesn't belong to any subset, or yeah, it doesn't belong to any subset of closed interval 0 comma infinity. Karpagam, you're right. Mahesh, you're right. Praveen, yes, range should be the subset of 0 comma closed interval 0 comma infinity. Yes, you're all right. So trivially, range should be a subset, and here the range contains set -1 comma 0, and set -1 comma 0 is nowhere a subset of closed interval 0 comma infinity. Hence we can confidently conclude that this cannot be a metric on any set M. So continuing, but we noticed some examples yesterday. They are of some importance, and we will recollect it. I hope you have made a note of it in yesterday's sessions. So let's continue with the next question. Prove that rho of x comma y is equal to x minus y when for all x comma y belongs to R cross R is not a metric on R. Think about this question. Give me your answer in another 30 seconds. I'll tell you when you can type in the answer. You can type in the answer and key when I tell you. Please post. I'm sorry about the loss of connection in between due to high internet usage. The of late due to this lockdown, there's been reports of internet lag everywhere since everyone is working from home and the internet usage has shot up infinitely. So I'm sorry for the lag, and we are in a lockdown. We can't do anything about it to make it better at this moment. Anyway, you can post your answers right now. So can we extend fourth condition? That is yes, Praniti, I'll address that question in a moment. Let's finish this question and I'll address the question you're asking about. And yes, it is very much possible. So you can answer this particular question right now. Pranidhi, your question, I'll answer it after this question is done. Mahesh feels that when x is less than y, rho of x comma y is less than 0, hence it is a contradiction. And Jocelyn easily pointed out that it is not symmetric, that is, the third condition is not satisfied. And Gerald also feels the same. Bijal, rho of x comma 0, yes, again what Mahesh said in a more specific way. So there is something interesting I can point out there. Mahesh was thinking more in a general sense. Bijal took a specific example and she was able to do it in a second. So that's a trick that you should master when you're going for CSIR-NET. In this question, general setting and the specific example doesn't make much of a difference. They take equal amount of time. But in certain cases, the general setting may take some more time than specific example to solve. So yeah, so yes, Pranidhi, that's true. Then in that case, when x is greater than y, things are all right. But when y is greater than x, this function will take value less than 0. Now going back to Pranidhi's question, we have, just a second, let me switch to whiteboard. So Pranidhi asked, we have our fourth condition as d of x comma y is less than or equal to d of x comma z plus d of z comma y. Now what she asked is, can this be extended if there is a, say here x, y and z belongs to m. Now what she asked is, can this be extended to others? Suppose there is a k belongs to m, can this be further extended? We know that if k belongs to m, d of x comma z is less than or equal to, using k, we can write it as d of x comma k plus d of k comma z. So put this in here and you will have d of x comma y is less than or equal to d x comma z x comma k plus d of k comma z plus d of z comma y. Even otherwise, we can think about it in another way. This is one way of claiming what Pranidhi said. Another way is d of x comma y is definitely less than or equal to d of x comma z plus d of z comma y. Now we know that the value of a metric is always 0 or positive. So if you add d of say x comma k, it's adding a 0 or a positive number. So this inequality stays intact. So that's two ways you can prove the same claim, that it can be extended the way Pranidhi claimed it to be. Is that clear, Pranidhi? Is your doubt clear? If you have any further doubts, you can leave it in the comments. Either I'll address it straight away or Vivek will. I don't know why, for some reasons the YouTube is having some issues. Anyway, I hope it's back online now. I hope it's back online now. Okay, so let's continue with the next challenge. Now I'm going to continue on the previous function itself. Rho of x comma y is equal to x minus y. On R, this doesn't work as a metric. Oh, I forgot to mention something. Notice that here I am tweaking the terminology a bit. So far I gave x comma y belongs to R. Here I've given the tuple x comma y belongs to R cross R. So keep that in mind. This and that means exactly the same. So in question, pardon Pranidhi sir, in the last question, 1 comma 15 is not sufficient if add many ordered pairs in 4 conditions. What I was saying is pardon Pranidhi, I didn't get your doubt clearly. Which one, Bijal? Which one do you want me to repeat? The idea of R cross R, is it? Pranidhi, can you clarify your doubt? And Bijal, what part are you asking about? The R cross R part, is it? So Bijal, when it is so far, I mentioned, I'll switch to the whiteboard. So far, I mentioned, I have to talk about rho of x comma y. I mentioned comma y belongs to, and right now in that particular question I have given x comma y as a tuple belongs to R cross R. Now, what I meant to say is these two are the same. Hi, is the video back alive? Hi, is the video back alive? Hi, is it back visible again? Hi, is it back alive? Just to confirm. I hope the video is back alive. So can we continue our discussion? So let me quickly repeat. R cross R is so whenever I mention of x comma y, I always mention x comma y belongs to R. And in this particular question, I have said x comma y tuple. Notice that I put it in a tuple belongs to R cross R. So that is what I mentioned, Bijal, that I have made a small difference in notation here. In the notation, I have made instead of putting x comma y belongs to R, I put x comma y tuple belongs to R cross R. That's what I mentioned. Anyway, let's continue to the next question. So I'll display the question. I'll give you 30 seconds to go through it and post your thoughts. The question is simply, can this work as a metric for 0, 1, closed interval 0, 1? So the same metric which we defined in row of x in previous question, challenge 10, row of x comma y is equal to x minus y. Can this work as a metric on the set closed interval 0, 1? You can post your answers now. This is a simple question, so post your answers straight away in the chat. You can post your thoughts in the chat here. Why? That's good thought, Praveen. Why do you think it doesn't work as a metric? Post your thought on why is it not a metric, so that others can understand as well. It's a simple question. You can quickly do it. I'm sorry about the relay. Internet is working perfectly fine, but for some reasons YouTube has been acting a bit jittery recently because a few of my videos were lost and it got deleted by itself. So in some cases the videos are there but visuals have been lost and things of that sort. I'm sorry about the confusion with internet. Yes, Karpagam. No, again, the reason Mahesh gave earlier in a more general sense of x being greater than 0, in that case, it is still minus 1. So, same question asked in two different ways. But I'm sure at least one of you would have thought, okay, now all the numbers considered here are positive. Hence, this may work, right? So, that's what I wanted to point out. This is where they try to trick you. They try to make you think in a certain way, and then at the end of the day in this entrance question paper, they'll give you something which looks okay. You sometimes would prefer not to think deep into it. You'll be like, let me save time and answer it and go ahead. But be careful. They would trick you into answering the wrong one. So think before you proceed. Now let's go to the next question. Simple again. Consider any non-empty set M. We are considering the function rho of x comma y is equal to x plus y. Can it be a metric on m is equal to r? And the second question, can this work as a metric on any set? So think about it, type in your answer. When I tell you can post it. Meanwhile, to keep to get updates about our channel and everything that we do, you can follow these different methods, or you can follow the channel and you can subscribe to the notifications if you want notifications about the videos we post and the content we deliver. So far the channel has been focusing on CSIR-NET aspirants and to make contents for them. But right now we are going to make it more general. We are going to talk about history of mathematics. We are going to talk about definitions, examples. Instead of just simply preparing you to clear an entrance examination, we will prepare you to clear entrance examinations. Along with it, we will make you learn how to think and work like a mathematician. And we will teach you things that is not generally quoted in classrooms. So you can follow all our works. The links are shared in the chat box. Anyway, you can post your answers now. Your thoughts. There are two questions. One, will this work as a metric on R? Two, can this work as a metric on any set? You can post your answers in the chat box right now. When you post the answers, you can also say why are you saying it. If you think that it won't work, say yes, there's a reason. No, there's a reason, so that we'll know. Yes, Karpagam, if x and y are negatives, or whenever the magnitude of the negative number is greater than that of the positive one, it fails. Yes, that's one way. So on R it won't work. Yes, shiny, rho of x comma x is not equal to 0 for all x. Almost you missed one particular x of x being 0, x and y being 0, x being 0, yeah. Mahesh, no, it should be a subset of 0 comma infinity. So Mahesh, are you saying that if m is a subset of 0 closed interval 0 comma infinity, it will work as a metric? Now, rho of Bijal, rho of 1 comma 1 is equal to 2. Yes, that again. This, okay. Lavanya said rho of x comma x is not 0 if x is not equal to 0. Mahesh, yes, as you pointed out, singleton 0 works. It will work in, yes, again, Praveen, you're right. Only in the case of singleton 0, this works. In rest of the cases, this metric will not work. Notice that through these challenges, I am also presenting more counterexamples. These are all simple counterexamples which will help you understand the definition better. So make a note of these as well. They look trivial, but they are also teaching you many things about this definition. They are helping you think about how to apply this definition, how to apply these conditions, see whether this condition is true or not in a specific condition and a specific case, and so on. Now, I'm going to next question. Give more functions like challenge 13, which has right domain and codomain, but fails at least one condition. So you can all leave your thoughts as you go. As in right now, you can leave it in the chat. I'll wait for 30 seconds. You can post at least one function that you can think of which will not work as a metric. Try to construct a function of x comma y. Domain and codomain are correct, no issues, but it fails at least one condition. There's a small typo. I meant challenge 11 to 12. So construct a function which will not form a metric, but it has right domain and codomain. So you'll have to first choose a set and then choose a metric for that particular set. You can leave your answers now. We will not spend too much time on it because it's a vast ocean. You have uncountably many functions which you can list here. So just list at least one that comes to the top of your mind. Construct one counterexample in your mind which will not work as a metric on some set that you choose. I hope you do notice the difference between the questions as well. In previous question, you were given a fact and you are asked to process. In this question, you are asked to create a new idea and it requires training. So that's what I told you earlier. Learning mathematics is not it's a fun thing where you should train yourself to think like a mathematician. You train yourself to create mathematics. Anyway, Mahesh and Vijay have posted their thoughts. Any non-zero constant function with perfect domain and yeah, any. So any non-zero constant function with perfect domain and yeah, that works. Yes, that's true, Mahesh. Any non-zero, any function which cannot take zero, any constant function that cannot take zero will work as a example. Now, Bijal, yes, m is equal to closed interval 0 comma infinity and codomain with row of x comma x is equal to x. That is, you're just redefining row of x comma y can be anything, but row of x comma x is equal to x. That causes trouble with the first option. Karpagam, yes, that's true. Row of x comma y is equal to xy. That will also fail because row of 0 comma 3, in case of real numbers, row of 0 comma 3 will be equal to 0, which should not be by our definition. But something interesting I should point out there is another object called pseudo-metric. I'll give you links on where to learn about it soon. It is something like metric space, but with a small difference in one of the conditions. I'll give you links on how where you can read more about it soon. Anyway, I hope there are no more thoughts. In case there are, just leave them in the chat. Vivek or I will get back to you soon. And good that you could construct examples and counter examples. So make this a practice. Once the session is done, go back, take a book, try to construct 2 or 3 more examples and counter examples. And that will help you understand the definition even more. That will help you understand how to create examples and counter examples yourself. From where, Bijal? From where did you miss the discussion, Bijal? Okay, so I was talking about how this particular question is different from other questions. In this particular question, yes, Bijal. So you mentioned row of x comma x is equal to x, and Vivek has clarified that maybe you meant row of x comma y is equal to x. But either way, even if you use row of x comma x is equal to x and row of x comma y is equal to anything else, if you split piecewise definition of this function, as you said, row of x comma x should be equal to 0 according to our first condition, listed condition. Hence, that will not work as a metric. Now, Karpagam's example is also very valid. So let me get back to this question. I was also talking about how, given how this question 13, challenge 13 is different from other questions. In challenge 13, I am asking you to define a new example by yourself, constructing an example or a counterexample by yourself. That's a mathematical thinking that I've been talking about in the first session, about how we should train ourselves, given a definition or a concept, how we should train ourselves to coin the examples and counterexamples ourselves. Especially when it comes to CSIR-NET, that's a very useful tool. If you can get examples and counterexamples yourself, you can easily answer most of the questions there in less than 10 to 15 seconds. So getting back now, once this session is done, I also mentioned about how you can try to create more examples and counterexamples once the session is done, and get back to us either personally or through Telegram or through any of the channels mentioned above. You in the Facebook page, you can always leave a message and we'll get back to you as soon as possible. So try to construct more examples and counterexamples. Especially in case of metric spaces, we can easily construct hundreds of counterexamples now because we have seen some examples already. Using that, extending it, you can create counterexamples. For example, x minus y is a counterexample. X minus 2y will be another counterexample. X square, rho of x comma y is equal to x square, y square will be another counterexample. You can construct hundreds of counterexamples now. But try to construct an example. That might take some thinking and practice. You're able to construct a counterexample easily because we have talked about so many counterexamples here. And you have been trained to think on what pattern you can create counterexamples. So try to construct examples now and leave it in the comment. We'll refer to it later. I'm going to emphasize on the counterexamples once more. I'm not going to spend time on this particular question. I need you to construct a metric, not a metric, sorry, a function which fails listed condition 1 alone. It should fail only the condition 1, not the other conditions. Condition 2, 3 and 4 should be satisfied. Either you can create one or you can claim that this doesn't exist. 2, it should fail condition 2 alone. Either you can create one or you can claim that such a function doesn't exist. And similarly, construct a function which fails condition 3 alone. 1, 2 and 4 are satisfied. Also, find a function which fails triangular inequality alone. That is, 1, 2 and 3 are satisfied but not 4. It will take a long time, it will take a lot of practice, it will take a lot of thinking, but if you can do this, I believe you have hit a jackpot. You have mastered this definition already. So make a note of these questions, leave your thoughts either in the chat or in the groups. We can have a discussion in the group about this. Anytime that you're free, you can fire up a discussion, we'll get involved. So let's continue to the next question. And I hope you have made a note of this particular question. I'm going to slowly switch to ABCD for options because in 2 questions we'll be switching to CSIR-NET questions and discussing them. So we already mentioned that consider any non-empty set M, a function given by rho from M cross M to open interval 0, infinity cannot be a metric since 0 is not included in codomain. So we already mentioned that 0 should be there in the codomain for a function to be a metric. I'm giving you an assertion. Singleton 0 can be the range of a metric. That's my assertion. And there are 4 options. Is this assertion is true if M is singleton set? Second option, this assertion is true if M is finite set. Third option, this assertion is true if M is infinite set. Fourth option, this assertion is true only if M is countable. You can post your thoughts here quickly and we will continue with the next question. I have made an assertion and I've asked you to verify in which of these cases this assertion is true. Mahesh says A. You can mention why. Yes, Karpagam, you have also voted for A. Mention why is it true. Why did you choose A? So I have made an assertion here, Bijal, that singleton 0 can be the range of a metric. And then I have asked you in which of these four cases given here, four options given here: A, M is singleton; B, M is finite; C, M is infinite; D, only if M is countable. Which of these options are correct? Yes, Pranidhi, you have given the right reasoning. Because if it's singleton, we already discussed multiple times that row of x comma x will be equal to 0. That's the only possible value here since the range is 0. So only in the case of singleton this works. Let me mention something interesting. The same point we have talked about 3 or 4 times already. But in all 3 times, what I did is I tweaked the way I asked a question. Previously, I made some change. Right now, I said I'm making an assertion. I am asking you to see when it is true. It's the same fact, but it's about how well you know to apply the fact that you understood. You can by heart this fact that 0 should be in the range of a metric. But that's not going to help you clear any entrance examination or be a better mathematician. The fact is not going to help you. It is about how well you can apply the fact. And when you're preparing for any entrance or to be a mathematician itself, all you should look at is not to by heart or not to memorize facts, but to learn how to apply these facts in a question. I hope you understood what I am trying to clarify. So if there are no more questions, I can proceed to the next question. Are there any more questions? I believe there's a huge lag between the relay and the displaying of content in your devices. So I'm going to hope that there are no more questions and going to continue with the next question. Final question. Yes, Bijal. So the final question, consider the function rho from r cross r to closed interval 0 comma infinity given by rho of x comma y is equal to absolute value of absolute value of x minus absolute value of y. For which of the following sets will this function work as a metric? This is not exactly the absolute value. This is not exactly the absolute value metric that we talked about. There is a slight difference, and it's not a slight difference, it's a huge difference maybe. And question is, for which of these functions will this, which of these sets will this function work as a metric? So leave your thoughts in the comments. You can quickly do it because we are running out of time, I fear. So leave your thoughts in the comments. We will see how to take it forward. So Mahesh says A. So Mahesh says A. And any other thoughts? Would it work on closed interval 0, 1? Yes, Pranati. Yes, Karpagam, it works for B as well. What about C? And D? They are feeling left out. As Pranati said, let me quickly wind up this question. This works as a metric for all of these sets. In fact, if it works as a metric for R, it should work as a metric for all its subsets. Why? That's a mystery that I leave it to you. I'm going to make an assertion here that if rho is a metric on R, it will work as a metric for its subsets. It's very interesting because I'll show you an example pretty soon which shows that if rho is a metric on a subset, it need not be a metric on the superset. So yes, all 4 options are right. And to give you an introduction on how to write a proof, think about this. I'm making an assertion theorem here. If rho is a metric on a set M, rho is a metric on its subsets as well. Try to prove it. Try to write down rigorous arguments. Let's continue with our discussion. So it is a multiple choice question, yes. So let me quickly continue to the next question, next section. That's CSIR-NET questions. So there was an interesting question by Vivek that will this work as a metric for R? What about 1, minus 1? That's true. Will this? That's a really interesting thing. I didn't think about it that way as well. What about rho of 1, minus 1? That's interesting, Vivek. So rho of 1, minus 1 will be absolute value of absolute value of 1 minus absolute value of minus 1, which will be equal to 0. We are in trouble. Is it back active? So Karpagan just pointed out something interesting. We all finalized that R is a metric on R and everything, but Karpagan just said, what happens when x is equal to 1 and y is equal to minus 1? Rho of x 1 comma minus 1 will be equal to absolute value of 1 minus absolute value of minus 1, which is equal to 0, which is trouble because that cannot be a metric on R. So we just concluded that it works on everything, but we missed one small point. So, but I remember framing this question. I framed this particular question long back. That's why it didn't strike me all of a sudden. So what about the other three options? Now I remember the context in which I framed this particular question. So what about the other three options? Now, in light of this, think of the other three options. Think of the other three options, which of them will work? I believe I framed this option for one of the class tests, and I framed this particular example for one of the class tests. So for the other three options, B, C, and D, yes, Bijal, that's true. It works for all other three options. So very interesting example, right? Again, our claim that if it works for a superset, it works for the subset as well works here, because B is a subset of D and B is a subset of D, and turns out since it works on D, it works on B as well. And in fact, somehow C and D are related because they are just negative of each other. So it works on all three of them but not on R. Make a note of this particular example. Just make numbers. It should work. Yes, Vijay. So make a note of this particular example, and because this metric works on selected subsets of R, that is, in that subset, if all numbers are of the same sign, then it will work, and it contains 0. I shouldn't miss that. Else, if it contains numbers of different signs, this particular example fails. So it's a very interesting example. I'm pretty sure it will be a very powerful tool when it comes to solving questions. Anyway, let's proceed to the next section. Are there any more doubts? Yes, Bijal, that's a really good observation. Are there any more doubts? Note that I have quoted somewhere around 10 to 15 examples and counterexamples in this process. I asked you in the previous section, I asked you to construct an example. The previous section I had asked you to construct an example, and here is one example. Is it back active? Is the stream back alive? Yes, we'll come to it in a minute. Let's quickly finish these questions and then we'll discuss it. I have fear that I'm running out of time. Can you spare another 15 minutes? Can you all spare another 15 minutes? We'll finish this particular set of questions quickly. So, first question, June 2019, part B. For alpha belongs to R, let this particular function denote the greatest integer smaller than or equal to alpha. So, I believe greatest integer smaller than or equal to alpha. We call it the floor function in certain cases. So, we are going to define a new metric from R cross R. Definitely this metric is on R. D of x comma y is equal to floor of absolute value of x minus y. Question, which of the following are true? So think about it, type in your answer, wait until I tell you, you can post. Thank you, Gerald, Mahesh, and Bijal. I believe the internet is active and pretty stable, but somehow the YouTube is giving me trouble. My console is completely crashed. I am not able to get live information about the classes, but I hope it's alive and active. So in case the video gets paused, please leave a message so that I can know. So you can post your thoughts right now. This is a CSIR-NET question. I chose questions from CSIR-NET because many of you are preparing for it, as well as this is a credible source of questions. Good, valid, interesting questions are asked in CSIR-NET. So leave your thoughts in the chat and we will start the discussion. You can start leaving your thoughts in the chat and we'll start the discussion. Digital D of 0.1, 0.2 is 0, so it's not a metric on R. Option D is true. So yes, so option D is true. Done and dusted. And then anyone else? Please note something. Just because it is asked in part, just because I mentioned it's in part B when you're studying, especially when you're preparing for exam, just because you know that it's part B, do not stop with the right answer. Do not stop with the right answer. Explore all the other options and give me your response. In the exam, part B, you get one option correct, stop it there. But when you're preparing, is it back active, Bijal? Is it back active? Is the buffer back active? Yes, Pranidhi. B is also right. Somehow B is also right. Interesting, right? Are you able to hear me now, Bijal? Hello, Bijal. Are you able to hear me now? So, yes, Karpagam and Pranidhi. B is also true. B also looks true. Something is fishy. It's a part B question and option B and D looks true. Very curious, right? So, now, in fact, I was tricking you by saying it's part B. It is, in fact, June 2019 part C question. Those who wrote it will know that. And please note that the reason I put it as part B is to point out this one fact. When you are studying, do not always look for the answer. Do not even check the answer until you are 100% sure that you can't find. You are not able to do it by yourself. One, check it out. Check out each and every option. Try to find out why one option is right. Try to find out why one option is not right. Try to find out different ways in which you can tell that one option is right or wrong. Because when you are preparing, don't be satisfied with a mere answer. I hope I've made my point across, and in fact, as you pointed out, option B and D are correct. Option A and C, I leave it to you. For the sake of time, I'm going to go forward to the next question. But what I want to point out is uh, to answer this question, what level of knowledge would you require? One interesting fact I'll tell you, Karpagam is a second BSc student who just learned the definition of metric spaces. And she has been able to apply it and she has been able to find the answer. What I'm saying is, even though it is asked at MSc level, this almost all of the CSIR-NET questions are something which can be answered by a student of undergraduate level, or in fact, if you have followed the video, you can easily answer this question. So let me continue to the next question. Next question is going to be the same, but I'm going to tweak this question a tiny bit. So the difference is going to be this. Instead of greatest integer than or equal to, I'm going to use smallest integer greater than or equal to alpha. Slight variation, right? That is, we sometimes call it the ceiling function. Yes, Pranidhi, let me look at it. What about option C? Will it be true? Will option C be true? What do you think? What does others think? I'm going back to the previous question where we were using floor function, and Bijal has a doubt whether option C can be true. What do you think? What does others think? Maybe due to lack of time, we will leave that as a discussion in the group, in our Telegram group. So we'll continue with the Let me quickly proceed to the next question. We'll discuss that in the Telegram group pretty soon. So let me continue to the next question. Where I'm tweaking the previous question. I'm tweaking the previous question slightly to say earlier we used floor function. I'm going to use ceiling function now. Which of these options will be correct? What can you say about this particular function? Will it be a metric on R? I'm sorry, I have switched off the video to hoping that it will better the buffering, and I believe it has worked well. So try it, type in your answer, and you can send your thoughts right now on this particular question. You can send your thoughts on this particular question right now. The question is ceiling of absolute value of x minus y. Which of the following is true? First is d of x comma y is equal to 0 if and only if x is equal to y for all x comma y belongs to R. D of x comma y is equal to d of y comma x for all x belongs to R. Third option is d of x comma y is less than or equal to d of x comma z plus d of z comma y for all x y z belongs to R. Fourth option, d is not a metric on R. Which of these are true if we are using ceiling of absolute value of x minus y? So B and D again. Why, Pranidhi? What about A? Why is A not true? We are using ceiling, that is, again, considering the previous example, row of 0.2 comma 0.1 will be equal to 1. So that particular example we took earlier will not work. Yes, Manas, B, C, D. Why not A? Manas thinks C can also be true, and nobody else has voted for it. So why do you think C is true, Manas? Can you leave your thoughts? Then x is equal to 0.2 and y is equal to 0.1. Row of x comma y is equal to 0. Not exactly. We are using smallest integer greater than or equal to alpha. So here row of say d of 0.2 comma 0.1 will be equal to greatest integer, so smallest integer greater than or equal to absolute value of 0.2 minus 0.1, which is 0.2 minus 0.1 is 0.1. Greatest integer, sorry, smallest integer greater than 0.1 is 1. So Karpagam, that in that case that will be equal to 1, not 0, not 0. Vijay, is it back alive for you? For everyone else it seems to be working. When x is negative 0.2, what happens? Yes, that's true, Vivek. That's true, Karpagam. When x is 0 minus 0.2, what happens is minus 0.2 minus 0.1, you will have minus 0.3, and smallest integer greater than or equal to minus 0. No, there again, we are taking absolute value here, Karpagam, so it won't. In that case, we are taking minus absolute value, right? So what happens is minus 0.2 minus 0.1 will be minus 0.3, and taking absolute value it becomes 0.3. Greatest integer, ceiling of 0.3 is 1. So we are taking absolute value, ceiling of absolute value of x minus y. So the case Karpagam, again repeating, the case Karpagam said is minus 0.2 minus 0.1 will be minus 0.3. Absolute value of minus 0.3 is 0.3. Greater ceiling of 0.3 is 1. Hence, again, that particular example doesn't work. So what can we conclude? What about option A? So I leave it to you to think about this particular metric and this question. We are running out of time, so I'll quickly mention a few more things. First thing is, look at this particular question. Let X be a countable set. Which of the following are true? There exists a metric D on X. So yes, Pranidhi, A is right. Rethink about that question. We'll discuss that in the group anyway. We are running out of time now. When I extended it for 15 minutes, we are running out of time. So let me quickly mention a few other things. Now look at this question. This is a CSIR-NET question again. We'll not be discussing it now. Why I brought this question in is, this talks about completeness, countability, compactness. We haven't explored those definitions yet. But when you look at this question, question also discusses about the idea of metric that we discussed throughout this lecture series. So that's why I spend so much time on carefully trying to help you understand this definition of metric spaces, so that as we go forward, when you come across questions of this sort, if you are confident with the definition of metric, well and good, you're all set to with half of this question, and you will be able to answer rest of it. So with that small note, let me quickly show you one more question which I will not be having time to discuss. I'll post this in the group, Telegram group, pretty soon. We can have a discussion about it in the Telegram group, and I'll quickly talk about Euclidean metric, which Vijay wanted clarification on. So let me take a minute to talk about this as well. A magical tool which helped me clear CSIR-NET long back in 2016 December, 4 years ago, is the diary that I kept. I maintained a diary where I made a note of different things. I categorized it. Facts about topic wise. I divided my diary into different parts. One part, real analysis, facts, theorems, and properties that I noticed. I listed them together. A few pages later, I'll have examples and counterexamples. Topic, the concept wise, I list my examples and counterexamples. Few pages later, anything else important that I noticed about the topic that cannot be included in either this or the previous two sections, I'll have a section for that. And I maintained it for every single question, every single fact that I came across. I made a note of it in my I maintained that diary, and that helped me clear CSIR-NET easier. So I would recommend you to maintain such a diary yourself, and I would recommend you to make a note of all facts that you observed, all examples that you observed, all counterexamples that you observed in this particular series of lectures in your diary. Now, quickly going to Euclidean metric. We talked about absolute value metric and we called it Euclidean metric again. And we were in fact talking about something in general called Euclidean metric on r to the power n. So Euclidean metric on r to the power n is given by rho of x comma y, where this x is a vector of n points, y is a vector of n points. Distance between 2 points in r to the power n is given by summation of k is equal to 1 to n xk minus yk, the entire thing to the power 1 by 2. Now, if you put n is equal to 2, it will reduce to the simple case of root of x1 minus y1 square plus x2 minus y2 square. And if you put n is equal to 1, it will reduce to root of x1 minus y1 square, and root and square cancels out, you are left with the positive root, hence you are left with absolute value of x1 minus y1. So what I am saying is the usual metric on r can be generalized or can be extended, to r to the power n this way. And this is called the Euclidean metric. This series of metrics are called the Euclidean metric. When we say r to the power n, we mean with r to the power n is a metric space, we mean r to the power n along with this Euclidean metric. So on r square, that is r2, this is the usual metric. So on r1, the metric on r1 will not work on metric on r2. That was a doubt Bijal had earlier. It can be extended. It's a different function. It's not the same function. It's a different function. And this function will work on r square. Yes, Karpaga, you can mention your doubt in the comments. I'll quickly, while you type in the comment, I'll quickly go to the next slide where I'll quote one interesting example and I'll wind up the session with it. So, is it back active, Bijal? Is it back active, Bijal? Yes, Manas, is it back active? My console says it's excellent connection. Okay, so I'll quickly recollect. So I was talking about how this is a metric. The Euclidean metric can be extended to R2 this way, and this is called the usual metric on R2, but this is not the same as our usual metric on R. And in fact, on the absolute value metric that we took earlier, can be generalized to be rho of x comma y is equal to summation of x k is equal to 1 to n xk minus yk. So I'll go to the next example, counter example. So q, we are taking the set of rational numbers. A is a subset of q. The function rho from r cross r to 0 comma infinity. I'm going to define it in a general setup r cross r, and it's defined as rho of x comma y is equal to absolute value of x minus y if x comma y belong to q, 0 if x comma y doesn't belong to q. When this function is restricted to q cross q, it works as a metric on q. See what trick we are doing here. We are defining it in such a way that its absolute value of x minus y if xi belongs to Q, x and y belongs to Q, and on other points of R, we are saying it's equal to 0. When it's rational, it's equal to absolute value of x minus y. When it's irrational, it's equal to 0. So on this, using this particular function, it's a metric on Q. But very interesting fact is, it will not work as a metric on any subset which has at least one irrational number. So this is a very interesting and critical example. Make a note of it. This is an example where Q, the metric, works on a subset but not on the superset. So make a note of this example. It's a very interesting and special example. Earlier we noticed one thing, right? A metric which works on superset seems to work on every one of its subsets, but here there's a counterexample to say that a metric which works on a subset need not work on the superset. Now, let me give you another example which we already discussed in the previous question. D of x comma y is equal to floor of absolute value of x minus y cannot be a metric on R, which we already discussed in the CSIR-NET question, but it will be a metric on Q. But it will be a metric on, on Z maybe, not Q. It will be a metric on Z. Anyway, with that I'll wind up the discussion, and there are a few other counterexamples that we noticed, or examples that we noticed on the go, like a is equal to open interval 0 comma infinity. How is the value 0 for the earlier example? Which one, Bijal? This one. This is this the example you are referring to, Bijal? So I'm just defining my function to be so. I'm defining a new function rho. I'm defining a new function rho where rho of x comma y is equal to absolute value of x minus y if x comma y belongs to Q, 0 if x comma y doesn't belong to Q. Oh, that. Okay, I worded the definition wrongly. This is if x or y doesn't belong to Q. I worded the definition wrongly, the function definition. If x or y doesn't belong to Q, then it's 0. Just redefine it so. If x and x comma y belongs to Q, this is absolute value of x minus y. If x or y doesn't belong to Q, it is equal to 0. So I'm sorry, I worded it wrong, Bijal, I agree. So there are some extra reading materials that I want to point out. Any other properties of example 3? You can always explore. For now, we can explore it in the group maybe. I hope you have come to the group. I'll share the links of link of the groups pretty soon towards the end of this session, and you can join the group and we'll discuss it in the group, Manas. So here are some extra reading materials. So you can read more examples in Wikipedia. 2, you can always visit the article on metric in Wikipedia, and that's an interesting article. There is a lot more explained out there. You know the basics well enough now that you will be able to quickly read it and understand. And I talked about a slight variation of definition of metric spaces of pseudometric or semi-metric space. You can read about it in Wikipedia, and empty set, we excluded empty set in our definition of metric spaces, but in some textbooks they include empty set. They include empty set in their definition. So there is only one metric which is possible on empty set, if we consider empty set to be valid to define a metric on. And this particular link talks about it. There is one more example which is quoted. You can either scan the QR or the links are posted in the description below. And Manas, in the description we have also posted the link to the Telegram group to join the Telegram group and much more. So you can check that for more information. So with that, I'll conclude the discussion. If you have any doubts, you can always ask in the group. I've overshot my time much more, so I'll wind up the discussion for today. If you have any doubt, you can always ask in the group. We can always have a discussion. We are happy to have discussions. And or you can ask us in Facebook or any other media. One more thing, this entire coursework which we did online will be posted as an interactive coursework in our website. To get an idea of what we mean by interactive coursework, you can always check this particular article we posted sometime recently. This is a discussion on definition of set alone. It goes through different examples, counterexamples. We have given different types of questions like quizzes, different interactive contents of that sort. So this particular coursework will be hosted as an interactive coursework in our website. And you can always, we'll post the link about it pretty soon, possibly in another 2 or 3 days. Hopefully tomorrow Vivek will be going online with some topics in linear algebra or algebra. So if you're interested, you can always join us. And I hope we can conclude our discussion for today with this. I'll also post the link to join our to get in touch with us, the other ways to get in touch with us, including Facebook, Telegram, and our website. You can also subscribe to this channel and enable notifications to know about new videos posted and live classes as we go live. Thank you. We'll wind up for today.